In the previous video, we were discussing various patterns on differentiation. In this video, we are going to discuss few formulas on differentiating the trigonometric functions. So as we all know, trigonometric functions are sin x, cos x, tan x, cot x, secant x and cosecant x. Wherever we get these type of trigonometric functions, we can differentiate the same by using the formulas. So let's see those formulas one by one. So before we discuss about the formulas on differentiation of trigonometric functions, let us just recall the standard trigonometric table. Okay, so in order to find out the values of the standard angles on trigonometric functions, very simple trick we have. Let's just have with 0 and let's reach out 1 by adding a quarter part to each and every consecutive value. So to 0, if we add the quarter part 1 by 4, 1 by 4 again. After 1 by 4, add another quarter part to it, 1 by 4 plus 1 by 4, 1 by 2. So to this 1 by 2, add the next quarter part 1 by 4, that's going to be 3 by 4. So for these values, take square root and that will give you the values of sine theta values. So square root of 0 is 0. So sine 0 degree is 0 only. Square root of 1 by 4 is 1 by 2. So sine 30 degree will be 1 by 2. Next, square root of 1 by 2 will be, square root of 1 is 1. Square root of 2 is square root of 2 only. So 1 by square root of 2. So sine 45 degree is 1 by root 2. Next, square root of 3 by 4. So that's going to be square root of 3, that is root 3. Square root of 4, that is 2. So sine 60 degree is root 3 by 2. Next, square root of 1 is 1. So sine 90 degree is 1. That's it. So with these values, it is easy for us to reach out with the next set of trigonometric standard values. That is, for cos theta, okay, the values which we have entered in the sin theta table, we'll add it in the reverse order. That's it. So cos 0 degree will be 1. We are entering in the reverse order. Cos 30 degree will be root 3 by 2. Next, cos 45 degree will be 1 by root 2. Next, cos 60 degree will be 1 by 2. Cos 90 degree will be 0. That's it. So having the sine and cos value, it is easy for us to find out with the tan theta values. Since tan theta is equal to sin theta by cos theta. Okay, let us find out the standard values for the tan theta. So tan 0 degree will be sin 0 by cos 0. 0 by 1, 0. Next, tan 30 degree, that is sin 30 by cos 30. 1 by 2 by root 3 by 2. 2 and 2 gets cancelled. 1 by root 3. Next, cos that is tan 45, that is sin 45 by cos 45. 1 by root 2 by 1 by root 2, that is 1. Next, tan 60 degree, that is sin 60 by cos 60. Root 3 by 2 by 1 by 2. 2 and 2 gets cancelled. Root 3 by 1, which is simply root 3. Next, tan 90 degree, that is sin 90 by cos 90. 1 divided by 0, which is infinity, or not defined. That's it. Next, for cot value, since tan and cot are opposite functions as like that of sine and cos, okay, let's enter the values of tan theta in the reverse order here. That will give us the cot theta values. So first, not defined, that is cot 0 is not defined. Next, cot 30 will be root 3. Cot 45 will be 1. Cot 60 degree, that will be 1 by root 3. Next, cot 90 degree will be 0. That's it. Next, we are going to find out the values for cosecant theta and secant theta. Since we all know that cosecant theta is equal to 1 by sin theta. That is, sine and cosecant theta are reciprocal functions. Okay, so what we can do is, let's just reciprocate the sine values and we'll enter it here. Okay, so 0. When we are going to reciprocate, it is going to be 1 by 0, which is not defined again. Next, cosecant 30, that is reciprocal of 1 by 2, which is 2. Next, cosecant 45, reciprocal of 1 by root 2, which is root 2. Next, cosecant 60, reciprocal of root 3 by 2, which is 2 by root 3. Next, cosecant 90, reciprocal of 1, which is 1. See, reciprocal of 0 not defined, reciprocal of 1 by 2, 2, reciprocal of 1 by root 2, root 2, reciprocal of root 3 by 2, 2 by root 3, reciprocal of 1, 1. Now for secant theta, since cosecant theta and secant theta are opposite functions, okay, the values which we have entered in the cosecant theta, we'll enter it in the reverse order. That will give us the secant theta values. So 1, then 2 by root 3, root 2, 2 and not defined. That is secant 0 is 1, secant 30 is 2 by root 3, secant 45 is root 2, secant 60 is 2, secant 90 is not defined. Or one more way is, let's take secant theta. That is, we know secant theta is nothing but 1 by cos theta. That is, secant theta and cos theta are reciprocal functions. So when we reciprocate the cos theta values, we get secant theta. That's it. For a knowledge purpose, we have discussed this now. So first, basic trigonometric function, sin x. So d by dx of sin x, that is, we are going to differentiate with respect to x the sin function. So d by dx of sin x will be cos x. The function opposite to sin x, that's nothing but cos x. So when we differentiate sin x, the formula will be cos x. That's it. Suppose if we get sin 2x, then your differentiation will be cos 2x into 2. That's it. That is function of a function, chain rule and all that. That we'll discuss later. Now we'll just discuss the formula. So wherever we have sin x, that becomes cos x. Same way, d by dx of cos x. That is when we are differentiating the cosine function. The opposite of cos x is sin x only. So the formula here it will be minus sin x. That's it. Right? So cos x, that becomes minus sin x. Now next, if we are having a tan function, if we are supposed to differentiate it, d by dx of tan x will be secant square x. That's it. Next, if we have cot x, that is going to be minus cosecant square x. Remember, if we have tan and cot alone, the differentiation will be with squares. For tan x, it is secant square x. Cot x, it is minus cosecant square x. That alone we can remember. Next, if we get the function secant x and if we are supposed to differentiate it, the formula is going to be very simple. It is going to be the product of two functions, secant x and tan x. That's it. Right? For secant x, the differentiation will be secant x tan x. Now, if we are going to differentiate the function cosecant x, then the formula will be minus cosecant x cot x. That's it. Right? So these are the basic trigonometric functions for which the differentiation formulas are shown to you. Okay? From the next video, we'll discuss few problems related to the trigonometric functions, and then we'll step into exponential functions, logarithmic functions, and then inverse functions one by one. Thank you.